Hey, math moment makers. It's Kyle, and you're hanging out with Jon here as well. We are super eager to dive into an episode today where we're going to chat all about trying to elevate our math resources. A little bit of background here. If you were with us last week on Wednesday night, we did a live session with over 250 participants where we were unpacking why our resources need to change. And we even did change one of our, traditional textbook problems. Right there, Jon?
Yeah. And the reason why we're doing this particular episode is to bring you the ideas from that webinar, but also to remind you how you can do how you can make transformations to textbook problems, problems you've got, resources you have at your disposal. We want to make changes to those resources so we don't have to spend so much time looking or changing or building everything from scratch. So we want to bring you that here in this episode and also tell you about some of the things we learned during that episode from our participants and some of the pitfalls to watch out for when transforming your textbook. So let's do this.
All right, here we go. Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pierce.
And I'm Jon Orr. We are from makemathmoments.com. And together with you,
the community of math moment makers worldwide who want to build and deliver math lessons that spark curiosity,
fuel sense making,
and ignite your teacher moves. Well, welcome again, my wonderful math moment maker friends. As we mentioned in the intro, we're super excited. And actually, we are, ramped up to dive deeper into this idea. If you've been listening to the podcast for a while, back in episode, I think it's 60, 62, something like that. That was 100 episodes ago, we shared a webinar we did on transforming your math textbook. You know what? Our first session we did last week sort of built on that idea. And today we want to dive a little bit deeper into the why, why our resources need to change. And then also some of the things that we want to be looking out for when we go to try to transform some of our resources. We still have some friends in the community who are telling us that this is an ongoing pebble in their shoes. So that's why we're here. And that's why we have this 4-part webinar series going on all throughout the month of January 2022. But Jon, tell people a little bit if they are not in that webinar series. And let's pretend maybe they're listening to this in May 2022 or May 2023. Have they missed the boat or what can they do?
Yeah, sure. So what you can do is, since we're running 4 different webinar sessions, those sessions are going to be open indefinitely. So if you missed our first live session because you're listening to this 1 week later or when this episode goes live, then you get to join us for the second live episode. Like Kyle said, we are doing this every Wednesday in January 2022, so we can help you make those transformations this year. But if you're listening, say later after we're done and it's not January anymore, then hey, you can still go to makemathmoments.com/transform. That's where, hey, if you're ready to sign up and do episode 2 with us or the next session with us, that's where you're going to go to. Just register and you'll get the Zoom links. You'll get the links necessary for you to join us live. If you're following us later and you want to still watch these sessions, we are going to have the replays up at that link indefinitely. We've got that. We want to build this as a transformational tool that we can help as many teachers as possible to make these changes in their lessons so they don't have to scrounge the internet to find a brand new engaging lesson or go and pay money out of your own pocket from websites that sell you lessons or worksheets. We want to be able to do that easily because time is a factor, but we don't want to have to use our own finances to kind of finance our math classroom. I think that's a big issue right now because Kyle, there is a big push in math education, and I feel this especially on social media. To throw out your textbook, right? It's I have to use these new engaging math problems to engage my students. And hey, rightfully so. We want to engage our students as much as possible. We want to get our students, building and using their curiosity. We want to get our students thinking. And so it makes sense to ditch that book because most textbooks, if you're just following the textbook, like for example, when I first started teaching, and this is true for I think a lot of beginning teachers, Kyle, is that when you first start, you don't have a lot of resources at your disposal. You collect those over the years, and my default was to open up the textbook that my department head has given me and look at the examples in the textbook and use that as my lesson. I would say, hey, this is my lesson, example 1, example 2, and then I would assign questions from the book. And that made sense because I didn't have a lot of resources. I didn't know a lot about engagement at that time. And so when you look at those textbook questions to use those examples, there's not a lot of engagement happening there, right, Kyle? Like when you see those problems, they're all given up front. It's kind of like these text-driven questions. And it's not like kids are dying to solve these problems. And you are like, okay, guys, I'm going to show you how to do this problem. And there's no kid going, Mr. Orr, I really wanted to solve that to begin with, right?
Yeah. You've really, it's like kids are saying like, you know what? You've taken that pebble out of my shoe. I was really curious about, quadratics or Pythagorean theorem or whatever it was.
Right.
But the reality is, just like you said, is like, we're pretty limited, especially when you're fresh out of the gate, or if you're teaching a new course. Like it doesn't matter how long you've been teaching. If you're teaching a new grade or a new course, if you're a high school teacher, you come into it and you sort of feel like you're disarmed. You're a first year teacher all over again, right? Like you're trying to understand the curriculum or the standards, and there's so much going on there. But something that I think is really important for us to understand here, when we talk about transforming our textbook problems, we're going to talk a little more about this in this episode, and we did so in this last webinar, is that not every problem is maybe ideal to be set up for a transformation. So we're going to talk about like how you might eye that up. But then also we have to be thinking about when we're transforming these problems, we also have to think about how, like, the lesson structure we're using. So if you haven't listened to the episode where we talked about the real flipped classroom, like actually teaching through a problem-based lesson, this is the type of transformation we're talking about, okay? I don't know how you're going to create a curious, interesting, or a math moment with our class if your intention is to pre-teach everything and sort of tell kids how to do the problem, right? Because that sort of eliminates all that curiosity as well. So you could work as hard as you want to try to make a problem out of your curriculum or out of your textbook. You can try to make that problem better. But if you're going to do all the thinking, or you're going to do all the telling, and students are going to just sit there and receive, then you're not going to be successful in that journey. So once again, pause this. If you're like, I'm not sure what you're talking about, Kyle, what's this real flipped classroom? Head on back a few episodes, a few weeks back. We shared the real flipped classroom. We talk about a lot of, sort of our approach to teaching. And this session, or this podcast, is really going to be about, how we can start that transformation. And then also, like where to begin. And Jon, we talk about it a lot, but I think it's worth us diving a little bit deeper into this idea of curiosity. Our 3-part framework has 3 things. And the first thing we talk about is sparking curiosity. Let's dive into that a little bit, because, curiosity is one thing. Like, we've all been curious before, but like, let's talk about some of the elements that sort of, why is curiosity helpful? Like, I think we all would agree. It's like, when you are curious, you're like, yeah, that was great. I was curious. Your attention was piqued, but like, what about curiosity is important, and how does it help us lure students in?
Yeah, there's why we start with curiosity, because I think some people are like, we got to get them engaged, right? And so it's like, that's true. We want our students engaged, but the way we go about it is to capitalize on their natural curiosity. And that's why it's step It's part one. It's not step. Part one of our 3-part framework. And if you haven't listened to say the first few episodes of this podcast, way back in episodes 1, 2, 3, 4, we walk through the 3-part framework and specifically on sparking curiosity. But sparking curiosity, we want to build on that natural curiosity, because if you can get kids to kind of go, oh, or lean in and go, like that's what we want, right? Because if you can create that moment, then you've got the student who normally doesn't participate kind of going, I'm in. Or the student who's like, oh, I already know this. Wait a minute, there's something different here. Like, we need those moments. That's what can kick off these lessons. And so this session, we want to kind of bring in, like, how do I pick a problem and then make that moment happen? And that building on that curiosity is so important, because it change, your natural curiosity like changes or lures your brain. And it's like that there's like an unconscious moment, right, Kyle, that says like, I'm gonna look at this, and that your brain can't help it if it's super curious. Yeah. Like I've in the past always used like your favorite shows that have cliffhanger endings to episodes. They're creating that information gap, and your brain can't help it but go, I want to know more. And like there's that unconscious concentrating on that thing, getting you ready to go, hey, I want to know more. It's because you have an informational gap and you need to fill it. And so when we teach with our textbook problems, there is no informational gap. Everything is there. Everything is up front. You didn't even create this moment for you to go like, I want to know more. That's what we want to focus here on in this particular podcast episode, is how can I make that moment in with my students?
Yeah, absolutely. And something that I think is really important to note. So again, this like phenomenon, this like information gap you sort of had mentioned, this creates curiosity. And you and I talk about the importance of curiosity. I think everyone accepts the fact that like, yeah, curiosity, it would be great to get kids curious in my math class. But something that I think is really great, not only does it like draw you in almost unconsciously, but also it helps you to notice things that you may not have noticed before. So like if you were to think like an example that I brought up in last week's webinar, I brought up this example of a video. I wish I knew what the name of this video was, but I feel like it's been used a lot.
The gorilla video.
The gorilla video. Like when I say this in education, I feel like a lot of teachers have seen it, because it's from brain science, and it really just highlights how our brains are actually so powerful that they can actually block out information that is unneeded, unwanted. And a lot of times it comes back to sort of a survival instinct that we have in our bodies. Like it's innate to us to save energy, right? Like we have to save energy. And the more we think, the more energy we use or we consume. So it's like your brain is sort of making decisions all the time on what's important. Like think of your drive to work. Imagine you remembered every single thing that happened on your drive to work. Now, for some people, they might be maybe just around the corner. For me, it's like more like a 35-minute drive. That would be exhausting if like everything I saw on the way to work, my brain held on to, right? It's like, what do I do with all this information? I saw 500 cars. I saw these people walking. I saw all of these things, but your brain is like sort of making decisions on what's important and what's not. And curiosity is this way that we can sort of get students' brains to start noticing things and almost like, dare I use the word manipulate? Like, it's like we're manipulating their brains to want to notice more about our math lessons. And if we go back to this gorilla video, for those who are like, I've never seen this gorilla video, but there's a video of basketball players or some, people with in a video, they're passing a bat, like a bunch of basketballs around.
I put the link. We're going to put the link in the show notes. I found that while you were chatting.
Oh,
Kyle.
I love it.
So we're good. We're good.
The gorilla video. So if you check this out, definitely worth watching. Like this these people are passing a basketball. And before you watch the video, they say, I want you to try to count as many passes as you can. And it's sort of hard to keep track. So your brain is like working overdrive. Like it's like focusing on the basketball. It's like every time it passes from one person to another person, you're counting. And unbeknownst to most people watching this video, a gorilla walks by and you have no idea. It even like stops and kind of looks into the camera, and they go rewind the video and they play it back. They say like, so how many, you could ask like, how many gorillas were in the video? And people would be like, what are you talking about? You replay this video and you see it clear as day of a gorilla walks by. Like, it's not like it was hidden in the background.
This is a different video. This is
yeah, exactly. You're like,
I remember
the
first time I saw it
over my eyes. It's got to be completely different. And until you actually like scrub the video back, like the same video, like you use the rewind button so that they can see, it's like, no, I'm not switching tabs or anything. You realize like, holy smokes, my brain completely ignored this. So why we say this is because curiosity actually sort of gets you to focus on things. And then it primes you for new learning. So not only does it do you start to notice things like patterns, and it gets you thinking and drawn into this idea, but then it also gets your brain ready to actually hang on to more information. And these are all things that as math teachers, I think we can all relate to, right? When you teach an idea and then all of a sudden you're like, it seems like students had never even experienced it when you ask them about it a week later, 2 weeks later, a month later, right? So bringing curiosity in is so important, not only because they are engaged, but it actually helps you with the learning process.
Yeah. And so if we start with curiosity, that's going to prime that learning. And in this session, we want to talk about transforming in particular lessons, or picking a problem and then from your resources and then changing that so that it can generate that curiosity, if we can create that informational gap. So when we think about picking resources from or picking lessons from our resources, I think you have to agree, Kyle, that some questions or some textbook resources are better than others. So for example, you're thinking about, you know what, I can't just go into my textbook and go, okay, I'm doing chapter 3.2 today. I'm going to just point and I'm going to grab that question from the textbook and it's going to work. I'm going to be able to change it so that it can be engaging, because I think some are good and some aren't. And Kyle, what would you say, what would you, when you think about which ones are good for transforming and which ones aren't, what would you say is say like the golden ticket here?
Yeah, I love it. And this is so important, because I think in the past, and even if you listen to that episode way back in the 60s, like 61 or 2, whatever that was, we didn't really address this. Like we never really mentioned the fact that, we're not making a claim that every single math problem you've ever seen is an easy one to transform. Of course, you can transform all of them, but some of them require a lot of heavy lifting, like a lot of transforming, meaning like you're almost like maybe starting from scratch in a way.
Right.
And then others are like a little easier. So what we're trying to say is that, you want to identify which ones are going to be more helpful for this transformation. And then also, I think we need to also be clear that we're not talking about transforming every problem students ever engage with in math class, because we have this, what we're talking about is how do we transform a problem that would be helpful for our lesson, like for our problem-based lesson that's going to deliver a new idea, that it's going to spark curiosity, but then also fuel sense making to uncover some new learning, right? Or some new experience. We're talking about that. Like we want to create an awesome context, an awesome problem that's going to be great to run a problem-based math lesson. There are other problems that we don't want to transform, like that don't need transforming. Like something, if you're just giving students an extra bit of practice so that they can develop a skill, or so that they can better understand or deepen their understanding of a concept that you've already engaged a problem-based lesson in, those problems are fine. Like we don't need every single problem students encounter to pique their curiosity. We want to get them to a point where it's like, now that you're curious about this idea, here's some other problems where we want you to now kind of like flex your muscle a little bit and show us that, yeah, you've got a grasp on this thing, right? So you're getting better at this skill. So those are two things. And then I guess one of the big pieces is like, we want you kind of looking at your resource, and we want you kind of scanning. Like, so if you're doing a section on proportional reasoning, rather than trying to transform, maybe the first question in a textbook, which might just be 3/4 equals, X over 12, which is just a naked problem, that's not really that helpful for you, right? Because there's no context there. What we want you to do is kind of go to the problems that might be wordy. Like, word problems tend to be really helpful because a word problem often has a context built around it. And I feel like that's a great place to kind of start. If you go with these knowledge-based or these skill-based problems, they're not necessarily like ready to be transformed. You're almost starting from ground zero, right? Other than the quantities. Whereas you go to these word problems and somebody thought out a context, they sort of mapped it out a little bit. And something that came up in our discussion in last week's webinar, which I'll let you speak to a little bit here, Jon, is like, most of, like, we sort of reflected on most of the tasks and the lessons that you and I have created. And I'm going to argue probably, some of these others like Dan Meyer or, Robert Kaplinski or Graham Fletcher, like, we didn't just pull them out of thin air. They were usually sort of inspired by some of the things that we've encountered through some of these resources that people are telling us to ditch.
Yeah, definitely. Like most, almost, I think we are safe to assume that almost everyone that we have created and on our sites came from our experience with teaching math, and seeing so many different resources. So in I guess in a nutshell, we've pretty much transformed almost all of our resources from textbook problems. And I really like that you've said, like, if you think about some of those problems from your textbook that are contextual, those are a great starting point. We're going to give you 4 kind of things to look for in a moment here on how, once you've picked a problem, how to actually transform that problem. But another way to think about which problem to choose, you can choose problems that, or questions from your textbook or from your resources that are not contextual. They could be completely abstract. And the thinking behind choosing a question like that, or to start with for your lesson, is to think about your learning goal, right? So it comes down to starting with your learning goal and going, like, what do I want my students to know, and how can I get them to kind of get there? And that's that lesson that we talked about a couple episodes ago, about flipping your classroom, is putting your students in situations for them to experience or try different strategies to solve a problem before you teach it. So that's why it's so important to kind of link transforming your resource with how you're going to actually teach that lesson. So where we're talking in today about specifically how to pick a question and then modify it quickly, you still need to kind of like piece together the lesson transformation of not teaching it all up front. And so, for example, like, you could just pick a problem that is abstract, but if you understand the learning goal of, like, why, because you have to ask yourself that question, like, what is it about this lesson that's important for my students to know and be able to do in the big grand scheme of things of this unit? For example, I transformed a very, very abstract lesson a few years ago, really from it was a textbook problem, which was the learning goal was finding the distance between 2 points on in a plane. Okay, so if you think about originally my Kyle, I'm sharing my screen here. You see it?
I do.
Okay,
I see a lot of Twitter right now. I see a lot of TweetDeck.
Right, so that's not good. So Lee's going to cut that out, and I'm going to reshare. I'm going to pick the right screen this time. I thought I picked the right one. Here we go.
There you are.
Confirm. All right. So when you that particular problem from just two points, the distance between 2 points on a plane or in two-dimensional space or in a coordinate grid, in my class, normally the way I would have taught it, if I was teaching it from the textbook, the first few years of teaching, the first 10 years of my teaching, I would have said, you know what, we're going to learn this particular skill today. Let me show you the formula. Hey, look at this ugly formula, this distance between 2 points formula. Hey, we're going to look at the X part of this point, the Y part of this point. Hey, there's a second point over here. Let's label them. Let's plug it into the formula. Hey, look at that. Boom. We've got the distance between 2 points. Isn't that nice? How I transformed it, it was thinking about the purpose, right? Like, what's the big idea here is to look at the distance, and why is the formula helpful, and where does the formula actually come from? These are all questions you want to ask yourself, because if you can ask yourself those questions and answer them, you can get your students to experience this, and then it becomes a transformational problem. And so and what I did, all I did was, you know what, I put 2 points up on the screen. And I just brought up a Desmos screen and put 2 coordinates there. I did not label the coordinates at all. And I took away the grid. So there's no grid. It's just a white space. And I've got 2 points in 2-dimensional space. And I said, hey, guys, I got to do something. Can you guys find the distance between these 2 points? Like, find the length of that line segment. And, you know, students are like, what
the heck's he talking about?
Exactly. How am I going to do that? And so then they're like, well, we need some more information. And like, you've got some of that already anticipation happening with their brains. And so, okay. Oh, wait, I forgot something, guys. I forgot to put up the grid. Okay. And so then it's like, now I've got these 2 points on the 2-dimensional space, and there's a grid behind it, but no numbers on the grid. And so, is this enough? And so kids are starting to see that the 2 points line up, and they can see the spaces on the grid between the 2 points. And some students are already starting using Pythagorean theorem to find the distance between, because they can see a right triangle.
Or I even wonder, like, I'm sure in your class, like I'm anticipating that some would even like try to approximate, like,
sure,
like if I took a box and went see like the pieces this way, and I kind of measured it that way, you know?
Right. And so some of the students are doing that, and they'll say it's about this, so it's about this. And some students have used Pythagorean theorem to calculate it. I'm like, awesome. However, is that good enough? Like, we didn't see any numbers there. So how do we know what the scale is? Right. So some students will say, oh, right. Or they might even ask for that. Like, I don't think I have an answer that could be right. Maybe it's right, but maybe it's not. I assumed every grid was 1 unit long. So you have it in terms of units, but then as soon as I put a scale on it, it might change some of the answers. Oh man, all the grids were 2 units long. And so now we say, hey, do we have a better approximation of the distance? And so we've adjusted our answers. And then I say, is that enough from there? Or we've got kids now really leaning towards Pythagorean theorem. And then what we do is start to go, okay, well, we see a strategy. Kids are using the Pythagorean theorem to solve. And then what I start to do is go, hey, you know what?
The jerk move is coming right here, right?
Yeah. Like, do we really need the grid? Right. So it's like, here's 2 other points on the screen, no grid, but now you can see them in 2 space with the scale still there. So students are like, oh, darn it. Now I have to like make a grid, or can I do this a different way? And so students are starting slowly with these thin slicing of problems, building up the idea of using Pythagorean theorem to find the distance between 2 points on a grid or in space, and they don't need the grid, right? So that's one of the big ideas of that unit, or that lesson is, hey, can I do this? And really, it was, I took this very, very procedural problem to begin with. Hey, here's 2 abstract points to find the distance. And I said, you know what, what's the big idea? We need to be able to use Pythagorean theorem. That's the formula, really, to find the distance between these 2 points in 2 space. And we just stripped it down, which is one of the first things, Kyle, right, on the curiosity path on how to transform lessons. Kyle, let's talk about the curiosity path.
Absolutely. And before we do, I want to make it super clear and just kind of reiterate, because again, we are huge advocates of context when available and when appropriate. However, I want to make it clear, especially for our high school friends, especially those who are getting into more abstract concepts. Like, I would argue the distance formula between 2 points is sort of like it, like you have it for those watching on YouTube. You had the formula up on the screen. It's very intimidating for students. I remember teaching that concept to students and sort of just being like, blah, there it is. And I'm like,
right.
My students have enough experience with substitution and with like solving equations and all these things. So they're going to be fine. But the part that was completely missing again is like, first of all, they're like, why do I care about the distance between 2 points? And I'm not getting where that formula came from. And through that very, I guess, methodical process, through what we call the curiosity path, you were able to, without a context even, of course you could have said, it's like, here's Toronto and here's Windsor, or, wherever you are in the world, you could do that. You can add that. But Jon just gave you a perfect example of how you created that information gap. Right? That information gap was the key to that working for you in a sort of abstract sort of world, and you sort of nudged them along. So like, here's sort of an image that, as soon as you said Pythagorean theorem, I just wanted to share this. I'm sure you folks have seen this before, but when you kind of like, you set students up to sort of want to find out this new information. So for example, another way we could have, if let's say you back up to Pythagorean theorem, another way we could have gone about this was sort of like just showing them before showing this image. But like, if you had to get over to that building over there, how would you get there? Like, would you follow the path, or would you follow this newly created path, which you see everywhere in the world around us? It's like, it's intuitive to us as humans in order to take this shorter distance. So, there's so many different ways that we can inspire curiosity. But what Jon just showed was sort of an abstract way of approaching the curiosity path. So this knowledge or information gap that you created really involved the first step of the curiosity path, which is withholding information. Like, if you had to quickly articulate, Jon, like, what were some of the key pieces that you withheld in that particular test? Like, you thought about, I got to figure out the distance between these 2 points,
right?
But like, what were you actually holding back, and how did your thought process work when you were trying to, follow the curiosity path instead of just saying, here's a formula, let's just practice?
So if you think about the original problem in that particular textbook, in that course, we would have been, it was one of the practice problems. You think about it, it is a practice problem that we're doing, but most of that whole lesson would have been just practice problems like that. I would have taken the 2 coordinates of those points, and normally you would just use the coordinates, but instead what I did is I withheld some information. I didn't put any numbers right on the screen to start with. I put the points on the white space of the graph without any grid. And so we've withheld all the numbers, which is you can do wonders with numberless word problems or numberless. Sometimes we call them naked problems. Like you can do a lot
contextless. Is that what you're saying?
Yeah. Contextless, but also sometimes numberless, right? So it's like, because you can have context, but then no numbers, or numbers and no context. And so there's going to be a lot of discussion in thinking and problem solving happening without any numbers. And so when I put that up, we had to think about how would we calculate this without any numbers on that grid. And so then when I give them the grid, there's still no numbers, right? But then students were in that lesson starting to build the idea of using the Pythagorean theorem to find the distance between, even though there was no numbers on there, they could count and make up numbers to say, hey, I think this grid space is 1 or 2 or 3, and I can calculate what this is going to be. And you said some kids might count. So the key idea there was withholding information and basically pulling everything away. And since there was nothing really there to begin with other than numbers, I pulled all that away and then gave them a visual. Sometimes visuals do help in a lot of cases, especially if you're pulling all the numbers away and the context, there's no context. So that is what I did to withhold information in that problem.
I love it. And the part that I thought was super cool too is like, and those again, watching on YouTube saw the screen share, and, you inch from like these 2 points that were in the first quadrant. Everything's positive. Everything's kind of easy and obvious, right? Like you're like, I can count the distance, on the X, and I can count the distance on the Y, and then like apply the Pythagorean theorem. And then, slowly you worked your way towards, and then you sort of created another information gap by like sliding one of the points into the fourth quadrant. And then it's like, now what? So it's like, you can't just subtract or I mean, I guess you could subtract the X values and the Y values. That's exactly what you're doing. But ultimately, I'm going to argue that for some students who struggle with integer operations, they can still look at that grid and go, well, I can see how far it is, right? So they just count the squares. It doesn't matter that some are in the negatives and some are in the positives. And then you can kind of go like, so now, and I liked how you said this, like, how can we do this without the grid? You know, so now it's like kids are deriving and they're generalizing this formula. And I would argue that, you know, this process, as you slowly sort of brought them along this journey, there was anticipation building, like not anticipation, like everybody's there, like so excited in your lesson that, you know, they can't hold it back anymore. Like we're not talking about that, but there's like, again, it's that information gap that sort of got you to go like, I wonder, like, you know, is my method like the easiest way? Or maybe some people are like super confident that their method is the easiest way, or is there another way, or like, what's going to happen next? Like, is there a formula for this, or every time do we have to actually like plot these points and count them up? And all of a sudden we're noticing and wondering. So again, go back to this curiosity idea. When you get kids curious, when you do these first two steps, right? And there's going to be varying degrees. I would say withholding information is always super important. And the anticipation is going to be a little different depending on the actual problem itself. However, those things work together in order to prime your brain to notice more things and wonder more things. Now, some of you might be saying, I've tried to notice and wonder, and, you know, maybe the kids didn't share as much as you wanted. We build that in the classroom culture, but also note that just because some students aren't sharing, they are noticing more. And they are likely wondering more, whether they've maybe explicitly realized this or not. Their brain is noticing more about that situation than had you just shared, here's the lesson, here's what we're doing. You know, like they're noticing more things, whether they're verbalizing it or not. Jon,
Totally.
Where do we go? Like, what's this like last step of our curiosity path?
So just in recap, since we're completely, you know, auditory here with the podcast, is we're talking about the curiosity path and how we can use that to transform lessons. And Kyle was walking through how I did that with this distance between 2 points lesson, and one being withholding information is key. That's the first thing you need to think about when redesigning word problems or any problems. Which builds anticipation. And how can you make that anticipation happen? And usually the withholding information leads to that. And then that will also prime kids to notice and wonder. And sometimes you can make that explicit, like, hey, what do you notice? What do you wonder about this? Kyle was talking about that. But then sometimes it's not that noticeable. Like mine, I didn't say in my lesson, what did you notice or what did you wonder? But kids were noticing wonders because I withheld all that information. And then that leads to the kind of the step that we say kind of like solidifies a lot of things and starting to kind of narrow down the focus, and we start to estimate or predict. And so that's usually where we call the curiosity path, those four things: withholding information, anticipation, noticing and wondering, and then estimation. In my lesson, the estimation it's not really like we estimated a number, but we were estimating or predicting strategies. Can also be your kind of estimation or your prediction stage. It's kind of like, I think this is what we're working on here. I think this is what my strategy might look like for finding the distance between this. I use the Pythagorean theorem. How does that look like? We end up getting to a place where we had a particular answer instead of saying just like, I think it might be this. So we didn't actually have our students estimate, but there's lots of problems where you could have kids estimate before that you give them the numbers to do any calculations, because that part, if you withhold the numbers enough so that they do the estimation and the prediction, that's the key idea for really problem solving and strategies to come out before those numbers come out. Because you can really, and if you listen to what your students are doing at that stage, you learn so much about their thinking on where they are on that particular learning goal before you even get to a lesson.
And Jon, I think, you know, going back to that, I think you just nailed it. I want to be super, super clear on this, because I think as well, just like we said about anticipation, for estimation or that predicting piece, sometimes it's explicit. Like you're explicitly saying, I want you to estimate this, or I want you to predict that. But oftentimes it's implicit. Like you did have them, like even early on, maybe you didn't even realize it, but when you shared those first 2 points, first of all, they were like, I can't even make an estimate or a prediction because there's no grid. As soon as there was a grid there, you could have some students kind of like eyeballing, right? And like, even though you didn't necessarily use the words, you were asking them to kind of, and again, it's that knowledge gap, it's that information gap, that withholding of information that's going to allow them, whether you ask for them to share it out loud or not, they're using that process, right? Like they're activating that skill, that thinking of estimating or predicting. So that right there, that is our curiosity path. We've shared it in many of our episodes before. So for some people, like, oh, it's the curiosity path again. Here's the thing. We've been working with so many educators for such a long time. And we've realized most recently that while people are like, we have some math moment makers in the academy that can recite the curiosity path. Like they know the 4 pieces, but they're still going like, what is it? Like, how do I put this into action? And that's what we're really focusing on here in this episode, as well as in our 4-part series. So from today's podcast, let's quickly talk about a few of the big takeaways. First of all, deciding which problem you want to transform. Do I just go and like kind of randomly grab one? You can do that, but that might cause you more problem or more struggle in order to make that transformation. So look at, kind of zoom out a little bit and kind of look at them and kind of scan them and kind of go like, which one might be a good place to start? And maybe the first one you pick isn't the one. Like, spend a little bit of time. If you're finding like, I'm not really feeling it, maybe try another one that feels a little bit, better. In sections like Jon mentioned, where they're like, it's pretty abstract, like distance between 2 points. Do I need context? Like, do I need to go to one of the word problems? Maybe I could. That might cause more work, right? Like I might have to go find a picture of, a map, and I might have to put the point. Like, if you want to do that, rock and roll. Or is there a way that I can create that information gap with maybe less work, right? Is, the 2 points example, I think is a great one for people to kind of reflect on and go like, maybe, that might be a good place to go for those cases where you spend 10 minutes looking and you go, I don't know, I'm not really seeing it here with these contexts. I wonder if I could just take something that maybe doesn't have a context and strip things away. What else did we talk about here, Jon, as we do big takeaways?
Yeah. So another big takeaway I think you should walk away with is thinking about the intentionality of the learning goal. I think that will help you a lot with that selection process of the problem that you're going to pick. It's like, what learning goal do I want to bring out in my students? How can I get them to experience that? And again, we'll just remind you to go back and look or listen to the episode on the real flipped classroom, because that kind of puts the pieces together of how that lesson can look, that uses what you're going to transform once you've picked that problem. And then finally, we talked about the curiosity path here, these 4 things you could do. A lot of it involves covering things up or with subtracting or repositioning a problem so that it gives less right away. And that can help you with kind of building that curiosity, right? How can we create that informational gap? Take some stuff away, see what you can take away, take it all away, and then see what you can bring in slowly with your students. So Kyle, hey, we had a great time chatting with you here in this particular episode. Where can you go to learn more about our next session? Or hey, maybe you're listening to this later and all the sessions are done, but you can still catch all the sessions. Kyle, tell them where to go.
Awesome stuff. Yes. If you head to makemathmoments.com/transform, that link is going to help you if you're like in the moment and you want to get in on these live sessions. Like we said, last week, we had over 250 educators from around the world joining us, like even some friends from the other side of the world joining us very early in the morning where they were. If you're joining us a little later here, like maybe you're new to the podcast and it's, 5 months down the road, you can still go to makemathmoments.com/transform. When you put your information into the box, you will get a 4-part kind of like an email series is kind of how that will work, where you'll get a video every few days where you can actually take part in this particular process with us. Because for those who have already registered and are joining us live, we've actually asked them to take the pledge to do this transformation with us. And we have some friends all over the internet sharing. And like here we have Kelly, who shared on Twitter that she's taking the pledge to transform, but not ditch, her math resources. And you can too. So she's got this. There's a nice little badge there. And really what we want you to do is we want you to make a commitment to yourself that you're going to try this process, because it is one thing. Like Jon and I have been to many conferences. We've seen tons of sessions and we've learned a lot along the way, but the sessions that have the greatest impact are the ones that ask you to take action. Let's not wait on this idea. Let's think about, like, what's a lesson that's coming up for you, and how might we be able to create that information gap? How might we be able to use the curiosity path in order to deliver a lesson that's going to create a math moment by sparking curiosity and fueling our sense making? Now, Jon, we want people to take that pledge. We want them to head to makemathmoments.com/transform. What is happening in this coming Wednesday? Like, this episode is going live, like right now, if you're listening live. And 2 days from now, we are doing this second session. What's going on in the second session? Because like, curiosity is amazing and all, but why do we care about curiosity, and why do we want students leaning in? What's the ultimate purpose here?
Yeah. So second session, actually, we're going to dig deeper into practical examples. We're going to look at how to actually apply that curiosity path. We'll reiterate with more examples on like which problems to choose that we talked about here in this episode, how to choose those problems, which ones, like what's our thought process on choosing this problem versus that? How do I piece together that kind of idea between like the lesson that unfolds and the problem that we're transforming? We're going to tie a lot of that together. We're going to give some folks an opportunity to transform one live with us. Then we're going to talk about what's happening there. That's session 2 which is called Setting Up for Success and the Curiosity Path. So we're going to do more on that because we do need more practice there. We can't just do this one-off, go, hey, I got these 4 things. No, we want to see some practical lessons that did this. We're going to do that together on session 2. Session 3 is the idea that if we're going to do this long term, if we want to make this a regular part of our routine, that we're gonna not only just take the pledge to do it once, but take the pledge to do it as many times as I can in my lessons, as long as I have appropriate amount of time. We want to focus on the fueling sense making part of the lesson, and so that's the part we're going to talk about in lesson 3 or session 3. How can I kind of mold the idea of the lesson progression with the problem I chose? And then session 4, Kyle, is kind of wrapping it all up and putting things together that we talked about, but also thinking about how does a lesson end? And then, like, because I think the endings of lessons are so important, and a lot of us don't consider that. And then kind of extending lessons, like what's the next stage? And sometimes we call that pivoting or proceeding. So we'll be talking about that in session 4. That's 4 sessions for you folks to join us to transform your lessons this year. And you can head to makemathmoments.com/transform. That will register there, and you will get all the information you need to take part in this transformation. All right, Kyle, that's it for us, I think, in this particular episode. Tell them about where they can subscribe if they have not yet subscribed.
Absolutely. If you are watching on YouTube with us, definitely hit that subscribe button and the like button. Leave us a comment. Really helps us reach a new audience. And then also, every week we've got a short video, kind of like a teacher tip video that we release on YouTube as well. So we're really trying to promote that. We've had a huge surge of subscribers on YouTube, which is fantastic. If you're listening audio, like Jon and I we listen to a lot of podcasts. We totally get it. If you haven't yet, hit that subscribe button and make sure you leave us a rating and review if possible.
Yeah. And also, if you're looking for some more support, always reach out to us on social media. We're at Make Math Moments on Twitter, Instagram. You can head on over to our free private Facebook group where we are sharing ideas. People are asking questions. A lot of support happening over there. Also, show notes and links to resources from this episode, plus the full transcript, is available over at makemathmoments.com/episode 163. Again, that's makemathmoments.com .com/episode 163.
Well, my math moment maker friends, until next time, I'm Kyle Pierce.
And I'm Jon Orr.
High fives for us.
And a high five for you.